I was talking about designs, yeah, all the research designs. I have also uploaded some papers, yeah, on size determination, and also I have separated PowerPoints, yeah, lecture notes as PowerPoint and as reading material. So please refer to the reading material, especially for sample size determination. There is one good paper on medical research, yeah, how to determine sample size. I hope all that will be helpful to you. And from time to time, I will also upload some of research paper which is relevant to dentistry. So let me continue with the sample size determination for today's class. All right. Um, so the learning outcome, according to the planner, we have to know what is the formula of sample size determination, estimation, sorry, and apply appropriate sample size estimation to answer research question. So from what you see here, whatever we are doing, we always go back to our RQ. RQ is our research question. And another thing that you have to bear in mind is that whatever sample size you're going to take, it depends on your method, yeah, your method, your sampling method that you use. Is it convenient sampling? Is it random sampling? Yeah, is it snowball sampling? It depends mainly on the sampling method. So let's first look at what is the sample size. This is a subpopulation to be studied in order to make an inference to an inference population. So when you are doing a study, of course, you can't study the whole population. So you're taking out a sample. Yeah. So from the sample, you want to generalize your study to the whole population. That is your aim here. Right. So the sample size, when there is a census, the sample size is actually equal to population. Let's say the government wants to study the population of Malaysia. So when they want to study the population of Malaysia, they have to take everyone into consideration. Yeah. So your sample size is your population. All right. So however, in research we can't be doing that because of constraint and also budget. Yeah. So normally we pick some day, and this sample must represent the whole population. And of course, the larger the sample size is more accurate the finding. But another factor here is time consuming and budget. Yeah, budget. All right. Besides that, availability of the resources, yeah, of the sample size, while the required accuracy sets the lower limit. So actually, you can take as much as you can, yeah, but therefore you can also get the minimum. We try to get the minimum, right? So when you take the minimum, that will be the lower limit, lah. So optimum sample size is very important in any research. Right. So a general thing, a general way of getting the sample is normally we say when the population is 10,000, we only take 1,000. That is 10%. If the population is 5,000, that means less than 10,000, we take 15% of the sample. So it is 750. So which sample has less standard error, and better quality? Right. So what is the sample size determination? So sample size determination is the mathematical estimation. So we use a formula, yeah, to study how many people you want to take into consideration into a study. So when the representative sample is taken from the population and generalized. And optimal sample size is required for the following reason. Why was it optimum? I told you just now we have upper boundary and the lower boundary. So when you take the correct amount or the optimum level of sample, so it allows for a correct, appropriate analysis. So you want to run a analysis, you must have the minimum number of people where you can run the analysis. Like for SPSS minimum you need 30. Yeah, you cannot take less than 30. Yeah, so then if whatever results you get is not accurate, right? To provide the desired level of accuracy and to allow the validity of the significant test. So all this you need to consider before you study the sample size. Right? If the sample size is too small, uh, here now due to the pandemic, yeah, we have a problem getting samples. Yeah, so if the sample are too small, even a well conducted study may fail. Well conducted study means if you have the correct methodology, you did everything correct, but if your sample size is too small, then your study will fail. It will fail to do what? It will fail to detect the important effect or the association. You are finding a relationship between two variables. So the results that you get might be it will not be accurate. It will be imprecise. Yeah. So this association will affect your study. What happens if the study is too large? The study will be difficult and costly, of course, time constraint, and availability. You cannot get the sample. Let's say you want to study a person with HIV and dental illness, dental problem. You want to study. So it's a rare disease, let's say, for example, a rare disease. So you can't get enough sample, right? And it might give you again a loss of accuracy. So that's why we need to have the optimum sample size. So when you have all these, when your optimum size is not obtained, what will happen? There will be random error, there will be biasness in your study, there won't be any reliability, there won't be any validity, and your null hypothesis, you have to consider your alternative hypothesis, all these will be affected. And what kind of problem you might face? You might have type 1 error, type 2 error, your power of the study, the strength of the study, the effect size, and the design also will be affected. Yeah. So all these will bring into the problem because of your sample size. So what am I trying to tell you here? What is random error? Random error is error that occurred by chance. Yeah. Sources are sample. Yeah. When you find the sample too small or too big, yeah, there will occur measurement errors. Yeah. Subject to subject differences. You cannot get the correct people for the study. Yeah. It can reduce by averaging, increasing sample size, or repeating the experiment. Right? So to avoid the random error, you have to increase your sample size. That is one factor. Other than that, you can repeat the experiment few times. Okay, that is random error. Systematic error, deviation not due to chance alone. The earlier one is because of the chances. Several factors. Yeah. Maybe when you select the patient, you have to exclude some of them, but you did not because you don't have enough sample. Yeah. So when patient selection criteria may be the contribution, you can reduce by doing a better study design in a proper way. Right. And then another one is precise. How precise is your study? Yeah. The degree to which a variable has the same value when measured several times. Just like your weighing machine, you take your weight every day. Yeah, every day you take your weight, but it's not precise. You take your weighing machine to another place, it shows a different reading. Yeah. So this one is called as it's not precise. So function as random error. Accuracy. Yeah. Accuracy. So to a degree which a variable actually represent the true value. So these are the errors that you can see. So the study you do might have very low accuracy but high precise. Yeah, so the random error is small. but the system error is large. Or high accuracy, low precision, you have a random error which is less, but the systematic error is small. Or you have high accuracy and high precision. You see the picture there, you aim at the correct place and very accurate. So we want our study to be random error small and systematic error also small. Yeah, right. Whenever we do a study, yeah, um, from the research question, we can narrow it down to our hypothesis. Yeah, hypothesis. Hypothesis, you have two type of hypothesis. Here I'm just picking a bit which is relevant to sample size. Yeah, about this hypothesis, I have another class on that. Yeah, I'll be talking about a null hypothesis. I bring it up here because it's something relevant to your sample size. So now hypothesis, we are stating that no difference between the group. If you are studying two group, you are telling the two groups, the group A and the group B, their mean are the same. That is our null hypothesis. Null hypothesis, we always assume that there is no difference. No difference between the mean, for example. Yeah, and you want to test. What I mean by no difference in mean, student who attend the class, yeah, online and face to face. I have two group. One is only online, one is only face to face. So I have two group here, group A and group B. So I'm telling group A and group B, doesn't matter they enter online class or they enter face to face, the performance is the same. That is my null hypothesis. Null hypothesis. No difference between the mean. That means I take average of online, I take average results of face to face. There is no difference, right? So in my alternative hypothesis, I can tell online class performance is better than face to face. Or I can say online face-to-face performance is better than online classes. So now the mean between the A and B is not the same. A could be better than B or B can be better than A. Two ways here. So here it contradicts with the null hypothesis. So if the alternative hypothesis cannot be tested directly, it is accepted to exclusive if the significant test rejects the null hypothesis. So here we have two types, one tail and two tail. Okay, what is one tail? What is two tail? If it is one tail, I'm telling A is better than B. A is better than B. Okay, so it is one tail. I'm telling one side is better than the other side. If I say two-sided, I'm saying that A and B not same. The mean is not same. So if I say two-tail means A could be better than B, B can be better than A. So got two sides here. So that will be two-sided. Yeah. So when you have two-sided test, yeah, what is your sample size? So all these factors will come into the determination of sample size. So you'll be thinking so many things to think about. Yes, so many things to think about. When I will tell you all the scenario that you have to think about, then later I will tell you which is the best alternative to get the sample size. Right. So we have just now I told you we tend to have type 1 error and type 2 error. Okay. Some of the slides will be repeated in the later lectures, yeah, because they are all interrelated, yeah. Right. So type 1 error. It occurs if the investigator rejects a null hypothesis that is actually true in the population. Whenever we do a research, we want to show that whatever intervention that we do is better than the existing one. That is what our aim, our what we have in mind. Okay, I just give you a simple example. Drug. You're going to introduce a drug. Uh, uh, Type 1 error is rejects a null hypothesis. You already said my drug is better. My drug is better, no side effect. So you try to reject your null hypothesis because your null hypothesis, you say drug A, has no difference between drug B. You're saying that it's the same. That is your null. So now after doing the investigation, you rejected. You say, oh yeah, my drug is better. Better in terms of side effect. So now what happened? Your type 1 error occurred. The probability of making an error is called of level of significance. So you are 95% sure that your drug is better. So it is specified as ZA in sample size computing. ZA is a value from standard normal distribution. Sample size is inversely proportional to type 1 error. So the bigger the size error, the less likely you make a type 1 error, right? Okay, type 2 error. Type 2 error, you fail to reject a null hypothesis. You're supposed to reject. Your intervention showed that your drug is better, but you actually fail to reject a null hypothesis that is actually false in the population. So it is called as type 2 error. All right. So it is specified in the term of ZB in sample size computing. Power. This is a probability that the test will correctly identify a significant difference, effect, or association to the sample should one exist in population. So sample size is directly proportional to the power of study. So your study is more powerful when your size sample is bigger. The larger the sample, the study will give a greater power on the significant difference. And then the next one is effect size. Normally the effect size, use this term when you want to measure the strength of a relationship between two variables in a population. The bigger the size of effect in the population, the easier it will be to be found. So the magnitude, how strong is the relationship between the two variables, right? For example, number of hours a student exposed to clinical lab, number of hours. That means you practice your skills in the lab. And the research shows that you are a better doctor. For example, a better doctor. So that is a relationship. Number of hours and a performance of the doctor. So they are related. So this one we call it as relationship. So how strong is the relationship? That one we have a test. We call this as Pearson test. How strong is the relationship R. Design effect. Geographical clustering is generally used to make the study easier. Just like when you do a study in your PIDC, it's easier when you take all your patients that come to the PIDC instead of you take all the dental hospitals in Penang. Right? It's cheaper and easier to do. The effect of the sample size depend on the number of clusters, the variance, and within the cluster. All right. The sample size for simple random studies are multiplied by design effect to obtain the sample size for cluster study. So these are all just introduction about the sample size. Odds ratio, this one you can just read it on your own. Relative risk. Relative risk is the ratio of probability of the event occurring in the exposed group versus a non-exposed group. This one I'll be talking later in other slides. Power analysis. When the estimated sample size cannot be included in a study, post hoc power analysis should be carried out. These are very high level of analyzing data. Yeah, the probability of correctly rejecting the null hypothesis is equal to 1 minus b, which is called as power. So post hoc power analysis is done after a study has been carried out to help to explain the result if the study which did not find any significant effect. That means after you did not find any significant effect, you can continue your analysis by using power analysis. Yeah, that is another branch of statistic. Yeah, right. At what stage can sample size be addressed? When you want to determine your sample size, you can determine during planning stage while designing the study using appropriate approach and information on some parameters. So once you already determine your variables, then you can determine your sample size. Yeah? Because from your sample size, you must get the correct design. If you are doing one group study, your sample size can be small. If you are doing a few group studies, then you need to have a bigger sample size. Or through a post hoc power analysis, you already did your first study and then you realize that your sample size is too small. Then you can do the second stage. Yeah, the second stage, when you are interpreting the result, you realize but in your case, you don't have much time to be doing all that. Yeah. All right. Approaches for estimating sample size depends on what? The study design. Again, it depends on your study design and the main outcome measure of the study. So there are different approaches for calculating the sample size. Depends on your study design and depends on the outcome. Yeah, what are you? So as we know that we have different study design, there are many different approaches because you have different study design. Such as case control design, you have cohort design, you have cross-sectional studies, clinical trials, diagnostics tests, studies, and so on. Design I already explained in the earlier lecture. Within each study design, there could be more sub-designs and the sample calculation can vary accordingly. All right. In my 1 hour presentation last week, I couldn't cover all the design. So in the Google Classroom, I already added other designs. Yeah. Under the topic, you will see design 1, design 2, design 3. Yeah. So I only managed to cover design 1 and 2. So I have uploaded other PowerPoint under design 3 and 4. Yeah, you can look at it. Yeah. Because our lectures are only until 10 hours, that's why whatever I can't cover, I will upload. Yeah. All right. So within each study design, there should be more sub designs, and the sample size will vary accordingly. Therefore, one must use the correct approach for computing the sample size appropriate to the study design and the subtype. All right. So I cannot cut short. Yeah, I cannot just pick and throw what I want to teach you. So when I teach, I need to teach a proper thing. Yeah, that's why whatever I can't cover, I give you for you to read up on your own or for your reference. For your reference. Of course, this one is not an exam paper, so you don't have to really memorize and all that. So it's more of a reference. So it's all there for you to refer whenever you are starting on your research. All right, the primary outcome measure is reflected in the primary research question study and depends on the study design. For estimation, the risk is a control study. It will be odd ratio, while for the cohort study, it will be relative ratio. So this one, when you want to calculate, the sample size, we also have to look at other things. Estimation, hypothesis testing, that you estimation is your confidence interval approach. Hypothesis is your test of significance. So test of significance here means what test are you doing? Yeah, is it chi-square? Is it t-test? Is it z-test? Is it f-test? Or is it p-value? All this goes under hypothesis testing. When are you going to reject the hypothesis? When are you going to accept the hypothesis? All right, depending on the approach chosen for calculating the sample size, one need to specify some additional parameters such as hypothesis, how precise, all this I have mentioned earlier, right? Okay. So there are 4 procedures. So finally, we are coming to the main part, how to calculate the sample size. We can use formula, we can use a table. I'm sure everybody is eyeing on the table. We have another one, nanogram, and another one, of course, is using the computer software. So we have 4 ways to determine. There are many formulas, yes. Even in the journals I have uploaded there, they have different way of calculating the sample size and power in different situation for different study design. So I cannot give you one formula, yeah, which is the best formula. It always falls back on your design. Yeah? The appropriate sample size for population-based study is determined largely by 3 factors. Estimation of the prevalence of the variable of interest, the desired level of confidence, and what is the acceptable margin of error. All right. To calculate the minimum sample size requires, these are what are the requirement. Yeah. Decide on the estimation of P to be measured in the study. Decide on the degree of accuracy, how accurate you want your study, whether it's 1% or 5%. Of course, 1%, yeah, is more accurate, yeah, than 5%. Decide on the confidence level that you want to use. Usually 95%. When it's Z, yeah, it's 1.96. Yeah, that means you are 95% confidence that your study is correct. Yeah. Determine the size of the population that the sample is supposed to represent. You must know your population before you determine the sample size, and decide on the minimum difference you can expect to find statistical differences. So when can you get? That's why this statistician, they are very good if they know how much sample you take and will show your results, which will show a success in your study. They know I take this much, make sure my study will be successful. The results will show successful. Whether it's successful or not is another story. But the results, we are interested in the result. That is where your ethics comes in. You trying to cheat. Whether it works or not, it doesn't matter. As long it shows my study works. That is where ethics come in. All right. All right. Okay. For the population, if you have population more than 10,000, which I doubt you have it in your study, all right? So N is the desired sample. So when your population is more than 10,000, this is the formula that you're going to use. Okay. What is Z? Z is the standard normal deviate, usually set for 1.96. Usually, so the Z value you put as 1.96. P is the proportion of the target, usually 50%, or you can, the values are given here, just put in 0.5. Q, population of the target population not having the particular characteristic. How many people are not having the characteristic? And D is the degree of accuracy required. Usually we set as 0.05 level, or can go until occasionally at 2. All right. So here, this is the formula that you can use. So for example, if the population, proportion of the target population with certain characteristic is 0.5, your Z is 1.96, you put in all the values, so your sample size is 384. See how big. So the minimum sample, if your population is more than 10,000, but don't worry, your population is not more than 10,000. Yeah. So that's why when students come and ask me, what is the correct sample size? This is the formula. But I cannot tell you this formula because your population is not so big. So when your population is not so big, normally I tell you just take 1% of 50, sorry, you normally take 15% of your population. That will be, that's how you justify 15%. Yeah, right. So this is the formula lah, when your target is more. If your population is less than 10,000, this is the formula that you use. Yeah. So for example, 1,000, your population is 1,000. Maybe PIDC 1,000, you take around 286. That is also very, very big number. Again, comes back to the study design. Can you get so many patients having that kind of disease? Yeah. Okay. If this is another one, when you want to break them to two groups. You want to have two groups. One is experimental group, one is subject control group. When you're doing treatment, you need to have two groups. If you want to have one group and you want to do a treatment, you insist, I only want one group. I cannot find another group. Yeah, you can do. That will be periodically done. Yeah, that means they have a time frame. So it depends. You see, you want to talk about motivation. You want to give motivation to your patients to come for their treatment. You know, among the society, there is a phobia seeing a dentist. Yeah, unless the pain is very severe. So the phobia, you want to overcome the phobia among your patients. So you want to give them awareness. So how do you do this awareness? Yeah, you cannot pick a group which got awareness, another group which do not have awareness. All right, which is not practical because it's being biased. So you pick one group. So you pick one group, you give them the motivation, or you give them the roadshow. After a time frame, you redo in a different form of awareness about how friendly the dentists are to kill their phobia towards dentists, towards doing scaling, yeah, feeling, whatever. So it will be periodically done. That you can do with one group, yeah, one group. But if you want to do a control group, you see, you need to get, you have to break them. So 184 one group, another 184. Or another way, use a ready-made. Now we are living in a fast world, fast food, everything we want fast. Even getting a degree, we want it fast. Everything we want it fast. Yeah. So we have a ready-made table. Yeah. How large a sample of patients should be followed up if an investigator wishes to estimate the incident rate of disease to within 10% of its true value with 95% confidence. All right, so you look at the table, you can get the sample size. Here is the sample size. Yeah, how accurate you want your reading. So as you can see, how precise it is, how confident you are in your study. The highest 99% confident. So you can see that your sample size is very big. As your sample size becomes smaller, that's why they say when your sample size is very small, the research, there is no strength in your research. No strength. And it's just do for the sake of doing. It does not imply anything. It does not contribute anything. Right? So that's the best way lah. If you want to use the table, yeah. Or when you have the sample, you look at the sample and then you can know how confident you are with your study. Right? So if you take 1,000 patients, 1,600, you're only 90% confidence with relative precise. How precise? Yeah, 0.03. So you can use a table. It's nothing wrong. Yeah. Another one is a nomogram to calculate the sample size. This one I won't recommend this. Yeah, this one you can look at here. Sample size from the study, number of patients required in each treatment. You can also look at this, right? All right. Use of computer software for sample size calculation. Software. These are the software available. Even SPSS can calculate for you the sample size. Yeah, and the power analysis, which I will be discussing later on SPSS. Yeah, so you can look into that. So when you key in, select the sample size and power, the population survey, how many people in the size of the population, yeah, how many standard error, what is your standard error, what is your minimum standard, and all that you key in, yeah, and then first you must know your research question, what study, yeah, I'm repeating this many times, all right. So sample size determination is the one of the most essential component in a research study. You can use formula, you can use a nomogram, yeah. You can also use the table, or you can use your software. So this is what about the sample size on my today's lecture. Okay. Now I want to continue. With still under the same unit, method and technique of data collection. Method and technique of data collection. Yeah. We have two types of data. One is primary data and secondary data. Normally, secondary data is already being collected by other people. The data is already there. Yeah. For example, X-ray. So X-ray, you want to study about the X-ray, the disease. You want to what you call that? You want to categorize your patients. Yeah, you want to categorize your patient. The data is already there. So it's called a secondary data. It's a very simple language. Primary data is the data that you are collecting now. Yeah. All right. So primary data, they are original sources. Secondary data, they are already, as the word carries, is a secondary. Yeah. Method of data collection, for primary data, normally you do observation, you do questionnaire, yeah, questionnaire, observation, interview, they are all done, considered as primary data. The original of the data is collected by the researcher, and secondary data is collected by other agency. For example, you want to do analysis on students' performance. So this student performance, if you're talking about the major public exam, the data is already there. You want to like teams. Teams is how well the students perform in science and mathematics subjects. You want to do a research on that. So the data is already there. It's a secondary data. Yeah. So you take the data and you analyze. So that is secondary data. You don't have much power to the data, right? Primary data, of course, will take more energy, more time. But secondary data is less time consuming. The last batch that did the research, they did on the secondary data. You know why? Because due to the pandemic, they cannot have access to the patients. So all their research was done based on the secondary data, right? Primary data is of course expensive. Secondary data is cheaper because you are not collecting the data, is already there. Efforts, more effort. Primary data, secondary data is less effort. Of course, primary data is more accurate, yeah, because you are there to see it, and secondary data is less accurate. All right, primary data is collected by the investigator. So method, observation, interview, personal interview, telephone interview, questionnaire, schedules. Right, observation method, this one I already talked earlier, but I'm talking here because I'm telling you that besides, actually here I'm trying to tell you what is primary data and secondary data, right? So advantages of observation method, you don't need the consent of the respondent, yeah. Subject respond bias can be eliminated if the observation is done accurately. Information obtained relates to what is accurately happening, yeah. So you're not judging the person from the past or future attitude, and this method is independent of the respondent willing to respond. Maybe you wait for few months or so, the person never show any wanted behavior, also possible, yeah. Limitation, although this method can be used to study sales technique, customer movement, customer response, but this method has certain limitation. Why? Customer state of mind, their buying motive, their income, education are not revealed. We don't know the subject we are studying, whether they are relevant to our study or not. Yeah. The method is time consuming. Interview method is also considered as primary data. Personal interview method is a person known to the interviewer, and it will be a face to face, yeah. And this is very accurate because it's a direct question. And the method of collecting data, primary data, depends on your framework, whether your framework is structured, that means you have structured there are less chances of misinterpretation. Yeah. All right, and a very expensive method, especially when you're covering a big area. Yeah, consuming. Under the interview method, you have to select your friends to train them to do interview for you. Like you cannot be everywhere doing interview, right? All right. And sometimes you need to meet the higher officials, where these higher officials, like CEO of the company, they got no time for this kind of question. Yeah. Sometimes it's the policy of the company. They are not supposed to reveal anything. So to collect a primary data is not easy. That's why I'm trying to tell you, it's not easy. You cannot approach them. So in these cases, you will mainly rely on their secondary data. And of course, there is a biasness. Telephone interview, calling the person, which is happening a lot now, and high rejection also. This kind of telephone interview, you will get a very high rejection, worse than online survey. Yeah, because people now are very busy and they got ways to avoid you. They say, oh, now I'm driving, oh, now I'm in a class. I cannot attend to the questions, right? Questionnaire technique. This one is a way of collecting your primary data. And it's a quite popular method lah. Yeah, popular method adopted by many private, individual, research worker, public organization, a lot. Yeah, all right. Advantage this questionnaire, even you don't know the person also, the person will attend. Yeah, attend to your questions. Is fast, lower cost than observation method. sometimes you, as I told you, you can email them. Yeah, people who you cannot reach out, you can email. Yeah, in past, some of the students have done this to the. They have emailed to the other dental colleges where they cannot get direct access to the help of the management, yeah, of PIDC. Limitation, of course, there are limitation when you do online questionnaire. People got a choice, yeah, whether they want to answer or not. Even I'm sure you have to assess your lecturers, yeah, assess their presentation, their teaching method, and all that. So we make it mandatory. How? If you want to answer, or you want to do your exam or anything, or you want to download, you have to answer the questionnaire. If you don't answer the questionnaire, you cannot get access. So we do a mandatory that, but you cannot be doing this to the public. Yeah, cannot. Inability of the respondent due to the lack of knowledge. Maybe they don't know much about what you're asking. Yeah, so that could be the limitation. So questionnaire, yeah, it must be always something relevant to our culture. Yeah, mustn't be sensitive kind of question and must be easily understood. That is the reason we are doing pilot test to know how reliable is our questionnaire. Yeah, pilot test. Must do a pilot test. Now, before you present, yeah, your presentation or proposal, there must be a pilot test, right? Uh, all right. And you must have a question can be dichotomous, yes or no, can be alternative answer, yeah, alternative multiple choice question, or could be in Likert scale, ranking order, yeah. And you must always leave a place to say, I do not know. So the person, if they don't know, they will say they don't know. They will, if not, your questionnaire is not valid, yeah. All right. It's not so relevant. As I talked just now, pilot study is to test the questionnaire so that you can make what you say. You can make adjustment to the questions, yeah, which is not clear. If you see the question, the same question, people are answering wrongly, that means the question is not clear. All right. And then secondary data, nothing much to talk about. It's already been collected. This may be published or unpublished. This data is primary data for the agency that collects it and becomes a secondary data for someone else. So it was a primary data until you use it. Then you used it, it becomes a secondary data for your own purpose. Right? So here we explain a bit lah on secondary data, yeah, from a published work, yeah, from technical journals, newspaper, books, even blogs, yeah, blogs. So if you see in the referencing, blogs are also accepted as reference, yeah, blogs, Facebook, Twitter, all these new sources of information. Yeah, it is. I have already given you in Mendeley referencing how to do referencing for blog, Facebook, tutors, and all that. Yeah. All right, so primary data are original in character because the researcher himself collects the data. Secondary data are not original, they are collected by somebody else and the researcher only makes use of them. Okay, so that's all for today's lecture. All right, so I will upload this in our Google Classroom and I will update you with more and more resources for you to venture into. All right. Okay. So that's all for today. And thank you very much. And I wish you a happy new year. Thank you.